HAZLOC cable and conduit seals. We're going to take a look at how these things are installed, what the differences are. So let's get going. First thing we're going to look at is a conduit seal. This is a conduit seal here, and what you'll notice is that it's, well, pretty basic. We've got a full opening through here, and we can open it in two places. So there's just a plug, there's a big opening there, and then a little opening down here. Now, on its own, it seems pretty straightforward. And I mean, honestly, how hard could it be? You got conduit coming in the bottom, coming out top, and you got conductors in there. And you only have access to the conduit really through this hole here. And what do I mean by access? Well, when we go to pour a seal, and I'm going to talk about an explosion seal first, we need to ensure that if it's a vertical conduit like this, that when we pour the sealing compound into this small hole here, it doesn't just all flow down through the conduit all the way down to wherever, I mean, who knows where it could go, right? We need to provide a blockage in here. And so what that requires is something highly technologically advanced. And that is a small cardboard box provided by the manufacturer. Appleton is a manufacturer of a lot of different explosion-proof gear. Now, what's inside the box? Let me show you. Prepare yourself. Yep, that's right, folks. It's cotton. This is cotton. And what we need to do is when we have a conduit like this, and we're pouring an explosion seal and it's vertical like this, we open up the big plug. We take cotton and we stuff it in, but wait, we don't just stuff it in willy-nilly. We're trying to create a dam down there. And in addition to that, we're trying to ensure that every conductor that comes through the conduit is completely surrounded by sealing cement. So that means I need to pack this so that the individual conductors are all separated. Not only separated from themselves, but separated from the wall of the housing. So you take a bunch of this stuff and you stuff it in, and you probably are using some little tools like a Terminator screwdriver, or perhaps even a pen, or I mean, anything, stir sticks, coffee stir sticks, extra pieces of wire sometimes I'll use to sort of move them around, but it is crazy tedious. And you can imagine beyond about 4 conductors, this is almost impossible. I mean, anyone could pour the seal, but let's face it, most of them, if they're over 4 conductors, they're not going to be individually separated. It's nearly impossible. And so this is 100% on the installer to ensure it's done right. So once I've got this wadding all packed in there and the conductors are going through, I close this up. And once it's all closed up and tightened, I've got a little housing in there. I open up the top plug, and now what we can do is get a funnel and pour my sealing cement inside the seal housing. So the cement is pretty basic as well. It often comes in a dry form, like just high compression concrete. This is Quickco. It's again from Appleton, and it's for sealing explosion-proof unilets. That's a unilet. I'm just going to call it a housing because it seems to make more sense when we're talking in English. And it shows you how to do it. You got to mix a certain amount of liquid with it, mix it all up, you pour it in, and then you put the little plug back in. Now, even if we've done this perfect, consider some of the drawbacks of using a system like this. First, it's 100% dependent on the user or the installer. If he does it wrong or he doesn't do it 100% right, the whole thing is, well, useless. Good luck trying to replace it. Second thing, what about the weather? This needs water. So if we're in -30 in northern province and we pour a seal and it freezes, what's going to happen? Well, if the seal freezes, as in the water inside the sealing compound freezes before it sets, it means it will never set. And then in the spring, what will happen is the water will separate from the powder, and the powder will simply be in its granular form, and it will never turn into cement. The water will simply evaporate inside the conduit. And then again, you have a completely useless explosion seal. So something to consider here. Now, what about if we're doing an FFM or flammable fluid migration seal? Well, these are a little bit more basic, but the same premise is still necessary to ensure that each of the conductors that goes through the conduit is separated and maintained a little bit of distance between them. In that case, you're using duct seal or silicone inside here, and there's no reason to really be pouring anything through the top. Now here is two separate seals that we have that have been poured, and you can see in the bottom, well, maybe you can't. There's a little bit of cotton there, and in the top, sort of open, and that's because this was a vertical poured seal. Now, if you try to take a look at the individual conductors in here, you can just barely see they have been separated so that there is sealing compound around each one, and hopefully it's not touching the side of the housing, but I don't know, it's kind of hard to tell with the camera here. This one here, same idea. It's a vertically poured seal, and the conductors, we need to ensure they're separated, but man, it is hard to do. So this is conduit seal number 2. If you had a horizontal seal, you would need to dam with cotton both sides, and then you would pour it in through the inlet here, or you could just pour it in through the big main opening. But you'd have to make sure you dam both sides, or else you're going to be pouring buckets of sealing compound in here as it flows out into each conduit, right? That's a huge waste of material. Now, what about explosion proof or sealable cable fittings? This is a sealable cable fitting. It's meant for tech cable. And what you'll notice, distinguishing feature, is that most cable explosion proof or sealable fittings will have a red collar on them. The red collar sort of allows for the separation of this secondary mechanism here. And when we go to put this actually on the cable, this is where the individual conductors will be sealed with the epoxy. This up here is really just a standard tech connector. There's not a whole lot really extremely fancy here. This is just the normal tech connector at the top. So what will happen is your tech connector goes in, or your tech cable goes in, you strip the conductors, the jacketing, not the insulation, but the jacketing from here on, and then you pack a putty typically around the conductors, or you can pour that cement in. Now, if we're using the putty looks like this. If you've ever seen the first Mission Impossible movie with Tom Cruise, there was a portion where he had gum and he sort of squeezed it together and it exploded. That's not nearly as, well, this isn't nearly as cool as that, but it's the same premise. There's two materials in here. There's a lighter blue and a darker blue. You get a pair of plastic gloves or vinyl gloves that come with this, and you take the putty out and you start to mash it. And when you mash it together, a chemical reaction takes place. It heats up a little bit, becomes a little bit more pliable, and you have a certain amount of time to form it before it solidifies. So often this is sold with cable fittings, but depending on what the manufacturer specifies, you could use it in conduit too. So what you would do is you'd squeeze it around the conductors, then you would force this down on top of the conductors, and then everything would get tightened up. You'd have this collar here, and then you'd have your entire tech fitting on this side here, and it would all get tightened up. So that would be an explosion, or rather just a sealable cable fitting for HAZLOC. Again, this could be either XP, explosion proof, or it could be FFM, which would be flammable fluid migration. Now, remember, there are different types of cable connectors. This is a standard tech connector. This is a sealable tech connector. Notice there's no red collar and there's only one collar, right? So that would be how we deal with our individual cable and conduit seals when we're in hazardous locations.